Hi everybody! So today's video is going to be about Unit 3, Lesson 1, which is Higher Order Derivatives. We have 3 learning targets today. The first is, I understand that differentiating f prime produces the second derivative, f double prime, provided that the derivative of f prime exists. So in other words, it's just sort of clarifying some vocabulary. What this is asking us to do is to understand that when we take the derivative of f prime, we get the second derivative, which we call f double prime. So just kind of the vocab of what's happening. The second learning target here is, I understand that repeating this process produces higher order derivatives. So in other words, as we continue to differentiate, if we repeat the process of taking the derivative, we get something called higher order derivatives. So the third derivative, fourth derivative, fifth derivative. Finally, I can use a variety of notations to represent a higher order of derivative. So the idea here is we have to correctly use the notation, and the notation that we use for derivatives oftentimes depends on kind of what we started with. Did we start with y? Did we start with y of x? Did we start with f of x? And that kind of thing. So let's start by just talking about what a higher order derivative is. When we take the derivative of a function more than one time, we call these derivatives higher order derivatives. Now, in this case, the word order basically means like level. So higher order means like the first derivative is the first order. The second derivative is the second order. The third derivative is the third order. So it's just sort of the level of derivative that we're working with. Each order of derivative tells us something different about the original function. So for example, one thing we already know is that the first derivative tells us about the slope of the original function at a single point. Now, the second derivative does not tell us about the slope of the original function. It tells us about something called concavity. So we're going to be learning throughout this unit what the different orders of derivatives tell us about the original function. Now let's talk about the notation. So notation here is going to be really important. And the reason is because you're going to see not only a variety of notations in the problems that you're asked to do or in the directions, but you're going to need to use the correct notations in the problems that you're asked to do or in the work that you show. So the notation here is really important. Let's say we start with a function that we're calling y. So if you start with y, one option for showing the first derivative is to write y prime. Now that looks like a little number 1, but it's actually a prime. It's almost like a tick mark. The second derivative, if we're going to follow this notation, would be y double prime. So you're going to see there's 2 tick marks now to show that it's the second derivative. The third derivative would be y with 3 tick marks. And the fourth derivative would be y with a little Roman numeral 4. Now, after 4, we just put the number. So for the fifth derivative, you would just put like y with a little 5 here. So after the number 4, we go, instead of writing Roman numerals, let's just go with regular Arabic numerals. All right, second, what if we're starting with y, but instead of using y prime notation, what if we were going to use the dy over dx notation? Now, the first derivative would be dy over dx. The second derivative would be d squared y over dx squared. Now, you'll notice that the squared goes next to the letter d at the top, and the squared goes next to the x at the bottom. And I'll explain why in a second, but I just want to show you the notation first. The third derivative would be d cubed y over dx cubed. And then the fourth derivative would be d to the fourth y over dx to the fourth. And you can see we're just going to, for each level, for each order of the derivative, we're just going to change the number next to the d or next to the x to show that kind of corresponding order. Now here's why those numbers go in different places. So one of the ways that we can show that we take the derivative is we say we take the derivative, which is d over dx of y. And when you take the derivative of y, that's how we come up with the notation dy over dx. If you use that same process again here, if we do d over dx of dy over dx, so now we're going to find the second derivative, which means we're taking the derivative of this again. You'll notice that at the top, there's an extra d, so d times dy would be like d squared y. But at the bottom, the entire dx repeats, which is why the squared goes at the end, is that that whole thing is squared, not just the d repeats, the whole dx repeats. And that's why those two numbers go in slightly different places, is because it all comes from this notation, meaning derivative of whatever's coming inside that bracket. All right, last but not least, what if we're starting with f of x? So sort of, again, a different ball game here. If we're going to start with f of x, then to show the first derivative, we're going to write f prime of x. To show the second derivative, we would write f double prime of x. The third derivative would be f triple prime of x. And pretty much after that, we just use like numbers, f fourth of x. Okay, now that we kind of know the notation we're going to use, let's practice finding a bunch of derivatives. So using correct notation, find the first three derivatives of the following functions. So we're going to find the first three derivatives of the following functions, and we want to use correct notation. For the first derivative here, I'm going to use just the y prime notation. So y prime equals, and I'm going to take the derivative like I always do. So 27 x to the 8th plus 35 x to the 4th, and then the derivative of the number 9 would be 0. For the second derivative here, I would just take the derivative of this first derivative. So you're taking the derivative again. So the second derivative, y double prime, would be, let's see, 8 times 27. I'm going to use my calculator for that because it's not something I know off the top of my head. Would be 216. So 216 x to the 7th plus 35 times 4 would be 140 x to the 3rd. Last but not least, the third derivative here, y triple prime, would be, let's see, 216 times 7 would be 1512 x to the 6th plus 140 times 3 would be 420 x squared. So it's really like, we're not really learning anything new here. We already know how to find derivatives. It's really just using the right notation when we continue to do higher order derivatives. For the next problem, I'm going to use the different notation. I'm going to use dy over dx just so that we can practice that one. So my original function here is sine. The first derivative would be cosine of x. The second derivative here, oops, got a little fuzzy there. Let me see if I zoom out a little bit. There we go. The second derivative here, so d squared y over dx squared, would be the derivative of cosine, which is negative sine of x. And the third derivative here, so d cubed y over dx cubed, would be the derivative of negative sine, which would be negative cosine of x. Now, one other example that I want to show you, and this is very typical of the types of problems you might see on an assessment or on the AP test. It says, suppose that you know dy over dx is equal to 3x to the 6th plus 8 over 4x to the 5th minus 1. Find d squared y over dx squared. Part of the challenge here is just recognizing this notation. So suppose that you know this, which means we already know the first derivative. And then it asks us to find the second derivative. And you have to know that d squared y over dx squared means second derivative. Now in this case, we just have to take the derivative of the first derivative to get the second derivative. So the second derivative here would be, In order to do this problem, I'm going to need to use quotient rule. So I'm going to do low, which is 4x to the fifth minus 1, d high, so the derivative of the top would be 18x to the seventh. So here's my high, and here's my low. Low d high minus high, which is 3x to the sixth plus 8, d low, which is 20x to the fourth, and low squared, so 4x to the fifth minus 1 squared goes down below. Now we could distribute combine like terms and simplify here, and if this was a multiple choice question, I might have to do that because I might have to make this answer match one of the answer choices. However, in this case, you've shown me that you know how to find the second derivative, so I would be okay on a free response question if you stop at this point. All right, thank you guys so much for watching. I appreciate it, and I will see you in class for some practice.